just to talk through a little bit about what's going on over the next couple of months. We have next week, we've got a company called Taraki who's doing simulation for models for automotive driving, autonomous driving, etc. We've got GM is hosting us for a discussion on active safety systems, a virtual workshop taking place on May 19th. Bell is hosting us for an end-to-end network slicing workshop on June 9th. We've got the TIP Open RAN working group, which for orchestration and automation, which is called Roma, on June the 23rd, talking through some of that orchestration automation stuff. And then, believe it or not, July the 15th, we're looking at 6G. So we don't want to get everybody hyped up about this is coming around the pike, but we thought we'd just share views from a certain number of people around, because we are seeing people starting to make moves, and we thought we'd get a pragmatic discussion about what 6G might turn out to be. July 15th. And then I'll just mention also Crown Castle's hosting us on August the 11th for a CBRS private networks discussion. So, Dave, that's me done. I'm going to hand over to you now. So I don't want to take any more of your time. I'll keep an eye on the chat box, so you don't need to worry about monitoring it. Feel free to comment in it when Bill's talking. You're welcome to do that. But other than that, I'll try and handle it myself. So, great pleasure to have Dave with us. He's just lost his video, so hopefully he's not fallen off a cliff or anything. But,
can you hear me?
Yeah, we've got you.
Okay. Oh, fantastic. You lost the video?
Just for a second there, yeah.
So, oh, okay. All right.
Over to you. Over to you, Dave.
Okay, fantastic. Well, thanks for that, Graham. It's great to be back on with the IWPC membership. Good morning, good afternoon, good evening. It does sound like we have a great global audience with us today, so I super appreciate everybody setting aside the time for us. Clearly, 5G and programmable infrastructure is a hot topic. It's also a big scope, and we've got a lot to cover. So I'm going to try and move fairly quickly through some intro slides. Really, no marketing, just to set up the use case and set up the presentation. And then I'm going to hand it over to my colleague Bill, who's going to provide a live demo. We're going to do it live over AWS. And we'll tell you, exactly what we're doing in a very methodical way and step you through it. And then we'll come back. We'll sort of summarize the presentation and review some benefits, and open it up to Q&A. We hope to do that all within the span of this hour, though some of these calls sometimes run over for those who can, and we'll stay on the line as long as anybody else wants to. Again, as Graham noted, the slides will be made available, and I did include some, for those of you who don't know us, I included some intro slides at the end of the deck, so you'll be able to pick that up within a few days or maybe next week when we post it. And there will also be a video recording, so you can like this presentation at a later time. So, I apologize in advance. I'm a New Yorker, so I speak fairly quickly. But I want to get through this subject matter so we can get into the demo which I think everybody's on the line to see. So, everybody on this call is familiar with the GP 5G standards. I'm not going to go into any detail on the standards themselves. I really put this slide up as just summary background, but also to point out that we're not focusing today so much on the much touted performance benefits, the promise of 5G. We're actually focusing on the operational benefits, right? The fact that the 5G standards, the service-based architecture and open APIs, is going to open up the door to virtualization, orchestration, and automation up to the application layer. And that also has a sort of knock-on opportunity as far as self-service customer portals, where enterprise customers could be taking advantage of network as a service. And that's what we're going to be presenting today. We're not only going to deploy the 5G core on bare metal, we're also, once that 5G network is established, we're actually going to then deploy a business application. It's actually going to be an IoT customer application. And we're going to deploy that over 5G slices provided by that newly deployed network. And we're going to do that all on the fly, and we're going to show you that, how easy and fast that can actually all be. So, as I mentioned, demonstration is going to present no-code platform-based workflow. So it's going to be a single workflow that manages the end-to-end. And that workflow is going to be essentially driven by a single unified model. It's a harmonized model harmonized standards-based model that includes all the metadata and domain semantics necessary to do this in a fully automated fashion, to truly have a programmable network. Instead of, there's lots of models out there, but the problem is the models aren't often connected. And then when the models aren't connected, then you're doing lots of manual integration again. You have these black holes where things aren't transparent. We're presenting a unified, harmonized model and approach so that you can have programmable infrastructure. We're very pleased, of course, to note that we are Amazon partners, and Amazon Telecom has validated the solution that we're about to present to you. We're actually doing trials right now with Amazon. And if there are any interested parties, feel free to reach out to me after the session, and we can discuss that. It's at EnterpriseWeb.com. So Amazon, I think we have some Amazon colleagues on the line as well. So we're doing this over Amazon today, and it's not just over their infrastructure, but also leveraging many of their services, and you can see a list there. We're going to be using the Open5GS for essentially open source 5G core, and as well as Fortinet. So it's going to actually be an enhanced 5G network with the security, and that business application or IoT application that I mentioned will be this home bridge application that I mentioned previously. So our CloudNFV solution, EnterpriseWeb, just in short, EnterpriseWeb, if you don't know our company, we offer a no-code integration platform, essentially for automated and agile operations. That's what EnterpriseWeb does. CloudNFV is our award-winning solution for the telecom vertical for this programmable infrastructure. So we're going to show you how our design time allows you to declaratively compose an intent-based network service, and how our runtime is essentially going to take a generated workflow and execute it to stand up that mobile core network. Once the mobile core network is stood up, then we're going to deploy a business application on it, and all of that's going to be wrapped with zero-touch autonomic lifecycle management. This is just sort of an iconic representation of a 5G network service with firewall. This was taken straight off of an Amazon Telecom blog. You see the link there. When you get the PDF, I believe this link is active. As far as the demo is concerned, even in the time allowed, with the time allowed, we can't do everything in front of you. So there are a couple elements that have been canned, and I'm just going to do full disclosure. In advance of this demo, so the presumption is that CloudNFV is in the Amazon marketplace. It was already ordered from an existing account, and it's deployed to Amazon zones running on EKS. So CloudNFV, our enterprise web product, is deployed as a cluster of pods running on EKS. That's already been done pre this call. Also, the onboarding was already done before this call, because we could easily spend 30, 60, 90 minutes going over onboarding, so we're not going to be able to do that today. So Open5GS was onboarded. Everything else, all the other solution elements were already in our catalog, so we didn't actually have to onboard anything else. So we have 150 or so, maybe now 200 elements, solution elements already that are very common routine elements. Everything from MariaDB to Metaswitch IMS already onboarded in our catalog. And generally, onboarding in our catalog, it's a model-driven process interacting with our type system. Something that's essentially a single component that's straightforward, like a firewall or a load balancer, that generally gets onboarded in like about 30 minutes. Something that's disaggregated, like maybe a Metaswitch IMS, might take 60 minutes. Something that's multi-component and has some rich complexity to it, like a 5G core or EPC, that can actually take a couple hours, because it's actually multiple components being onboarded and then being presented as a single service. So that's just to set that up and give you some background. Of course, I'm happy to present those things separately and offline. As far as the demo is concerned, we are going to go into the catalog. We're going to show you the catalog. We're going to show you objects in the catalog. We're going to briefly review the properties and behaviors, dependencies that have been modeled in the system, and navigate around the catalog a little bit. Then we're going to show you how a service designer can quickly, declaratively compose an enhanced 5G core firewall as an intent-based network service with no code, no manual integration, no coding events, no developing interfaces, etc. Zero code. The only code that's ever used in Enterprise Web is if there's a string or something that needs to be invoked to call some third-party product or service, then that gets brought into the model, but it's not actually coded. We're not coding in Enterprise Web. It's a no-code environment. So though we're going to spend 30 or so minutes in doing a live demo, most of that demo will actually just be going around showing you various aspects of the system, how different personas or users might log in and out of different products, and even customers, to essentially navigate the systems. But the actual only work that's going to be done is modeling the service graph, the service chain policies, and SLAs. That's it. That work will take 5-10 minutes. There'll be no code. And everything else will be reviewing the catalog, seeing the deployment, placing an order, seeing the deployment, placing another order, seeing the deployment, looking at the transaction trace, etc. So, that's the whole benefit of a no-code environment, right? You onboard things into a catalog, and then you point and click through a catalog, and you can compose things. And because it's all model-driven, not only do you have a high degree of automation, it's also very easy to adapt because everything's driven by metadata. So it supports service evolution and modification, substitution of various components in a solution, the evolution of as various components get updated. It's easy to do lifecycle management and version the entire service, version the individual components, etc. So a lot of advantages there. So you're going to do that modeling, and then the system is going to generate a deployment workflow for you. It'll be editable, but essentially most of the time it's used as is. So you don't have to tell the system the order of work. The system will automatically make as many tasks parallel as possible. You don't have to tell the system how to do exception handling.
Dave, just a time check. We're at quarter after.
Okay. You don't have to tell the system how to do lifecycle management or anything else like that. So, and then we're going to publish that to a catalog. Really quickly, we have one or two slides left. As soon as that an order for that newly published service is made, that's going to trigger CloudNFV to execute that deployment workflow. Right, so the runtime is going to execute that workflow, and the tasks are going to be contextualized for that service. So the stages of the task should be instantly recognizable, right? We're going to establish the infrastructure, we're going to instantiate the service, we're going to configure the service. They're essentially generic, as they should be. It's a model-driven system. But then the specific details are going to be specific to that service, right? In this case, we're going to be doing some code generation, generating YAML files for CloudFormation, JSON payloads for Amazon EKS, etc., as well as a JSON payload to configure DNS entries, and so on. We're going to deploy things onto the network that's been established, and then we're going to configure them as well. All one connected, end-to-end automated process. No manual intervention required. And it's fully transactional. If any of these stages of this process fail, the whole service deployment fails. And then, of course, once it's deployed successfully, it gets logged in an inventory, and if it and it's under lifecycle management. If it fails, everything's going to be released, and of course, notifications. The second part of this demo is essentially very similar. We're going to deploy that 5G IoT application. Essentially the same, similar generic workflow. This time it's much simpler. So the tasks are simpler. But it was all generated. Nothing is being manually done here. And that's it. That's the end of the demo. Once again, 6 seeds. It's an inventory and it's available. If it fails, it's all released. It's transactional, right? So we're giving reliable messaging and transaction guarantees because you can't have partially deployed services on the network. right? You would immediately lose control of your infrastructure. So the system is providing the controls necessary to make this scalable, stable, and performant. So Bill, with that done, I'm going to pass it to you.
Okay.
Okay, if you stop sharing, then Dave, and then Bill can share.
Okay. You should be able to see my screen now.
Super slick, Bill. Very impressed.
Awesome.
Okay,
Right.
over to you.
Wait till you see the demo.
Thanks. All right, it's great to be talking to everyone today. So I'm going to go through that demo that has already been pretty well set up by Dave. For the actual demo itself, though, I'm going to be playing a number of roles, as was mentioned. Everything from sort of a cloud administrator right through to that service designer and then the end user, right? So that business customer. And as I do it, I'm going to walk across a number of different components. So what I'll do is I'll kind of just, you'll have this slide so you can place it with the demonstration or recording later, but I'll just let you know what role I'm playing at what time and what sort of general task I'm doing. As mentioned before, this isn't really a tutorial, so I'll keep it kind of high level. I'll just concentrate on sort of the details here, but you're going to see me do everything live. And mainly what I'm going to be focusing on is this sort of third step, which we mentioned, the modeling of the 5G core. That's the only place where real work will be done. Other than that, it will really be a review. And I'll go across everything from some AWS services themselves to our individual modules, and then even a couple of customer portals that we sort of stood up as nice samples to show you what you could attach to some of our northbound APIs. So without any further ado, I'm going to start with the role of a cloud administrator. I'm just going to review what's already been deployed, as was mentioned. So what I'm looking at right here is just we have a nice little proxy for looking at CloudFormation stacks that have already been stood up. As we mentioned for the demo, there's two things. We've already been sort of push button deployed out of AWS. So there's an instance of EnterpriseWeb running. That's what you'll find up here at the platform. And you can see that here running already in our browser. Each one of these modules has full sets of APIs. It all can be, it's all cloud driven and all that kind of good stuff. So each one will have a user interface that we'll log into. But everything you see me do during the demo, you can also do through all of our APIs. So you can automate absolutely everything. The second part of it is that we stood up this sort of demo staging environment, right? So on EKS, we've just got a nice sort of bare metal Kubernetes to start with. We can query all the things like service accounts and so on that have been stood up. But basically, you can see it's empty here. It was pre-existing before the demo itself, and we stood it up with a simple CloudFormation template. So these environments are already stood up. But as a cloud administrator, I can go through the typical AWS tools if you want, or log into EnterpriseWeb itself and see where it's deployed and all that kind of good, all those kind of housekeeping details. So I'm going to log in now. I'm going to switch roles. So I'm going to come in as just a service designer who wants to look at the overall CloudNFV catalog, right? So the components or solution elements that have already been onboarded. And so we have a module for doing that. So I'm going to log into it. And all of this has RBAC and kind of role-based access, and it's really divided by roles. So our modules, we don't have time to get into right now, but there's a number of them that are sort of, if you want, tailored to the task that you're going to be working with. So someone who manages resources, for instance, has a module to do that. Right now, we're just looking at the overall catalog, and you can see that it really spans a lot of things, from cloud hosts, things like AWS zones that have already been onboarded or modeled, to things like controllers and third-party components. So there's a whole ton here that sort of span the whole spectrum of the kinds of things you would want or need to actually implement a network service, right? Especially in a zero-touch manner. So it includes all the things that would be typically manually integrated. Someone has an Ansible script, for instance, what have you. We have runtimes actually to support that, like in this kind of a case. So all that's in our catalog. You can look it all up, and based on your security, of course, you can go in and start creating instances, what have you. We're going to be composing a service in a minute. But if I wanted to look for things like, say, a firewall, for instance, what I would get is a search across. You can see there's a number of different components here, from a Fortinet firewall to an F5 and so on, that have all been onboarded in advance of the demo, right? And in this case, I'm going to just look for our open 5GS, and you can see that a couple of components here have been modeled as CNF/VNFs, right? The control plane modeled separate from the user plane, And we can drill into any one of these, and setting up that model, as was mentioned earlier, 30 to 60 minutes typical. If it's a little bit bigger, maybe a couple of hours. But what happens is that model is going to contain all the information that's needed to actually automate this thing. So it's not just an Etsy VNF descriptor, what have you. It's got the full kind of life cycle details, everything about deployment and so on that are going to be needed to actually stand this thing up and then configure it. So if we look at like something like the control plane, for instance, this is going to be a good example of the kind of things that we're looking at for an individual component. We can look at things like the inventory from here, a lot of things around case management, security, versioning, and so on. Or we can just start looking at the package, which is where we've encoded all the details about this component that we're going to end up using. And you'll see in other demos, or if you go through the onboarding process, that it's all a very similar kind of process. It's all there's an ontology behind this, or sort of unified cloud model that contains all the real details that are needed for automating this, or lower level things like if I identify that there's a particular interface, for instance, which is part of the onboarding process, the system will understand how to connect those things up, what protocols, formats, et cetera, to use. So I don't have to manually integrate this thing. You can see things like the NFCs, of course, that are modeled here, the various components that you'll already be aware of. Things like being able to use somebody's YAML scripts or what have you, if they exist. Things like Helm and so on can all be integrated into here very easily if they're needed. But as far as we are concerned, there's no manual code that's actually used here. It's just an onboarding process.
Bill?
Yep.
Hey, Bill, just also to give people a sense, this was not manually input, right? Through the onboarding process, through our type system, all of this was auto-populated, correct?
Oh yeah, exactly. And so, yeah, we won't have time to show you that in this particular demo, but yeah, any of the artifacts that you might be familiar with. So if you have a VNF descriptor, or you have a Helm file, for instance, as a source, you import that into EnterpriseWeb. It decodes it and really maps it to our model for you. It shows you what it's doing as it does it, so you can make corrections if you need to. But it does 90 to upwards, sometimes 100% of the effort for you right off the bat by automatically mapping these things and really just creating that sort of harmonized model that walks across. And basically, it makes these components actual, composable objects. So I can open up a graph, connect them, and I don't have to spend time manually coding the glue that other people would do in other systems. So in any case, I'm going to use this. You can see some of the details about it. There are a couple of things that are interesting, like, for instance, this user plane actually has a database that you can specify. There'll be a parameter that'll be used later, and you're going to see that these kinds of things are all, the system's going to be aware of the components that I bind. So the fact that this thing needs a host name that'll be inherited, when I start to compose this into a service, you're going to see some of these things will come in, well, a lot will just come in for free for me. So it'll be aware of the kinds of details that are required when I want to use this component. And I won't go into any of the other components, but suffice it to say, they're all modeled in here in a similar fashion. Just the details based on the type are the things that will differ. So I'm going to now switch roles, and I'm going to go in as a service designer. So specifically, I'm going to be using a different module, and it's just service manager. It's literally created for someone in this kind of a role who's going to be composing services or identifying existing services so that they can be used by the system or ordered or what have you. So I'm going to log into this particular module, this service manager.
Hey, Bill.
Yep.
Yeah, it's Graham. So a couple of quick questions for you that I've got here. So let me just read them out for you. Could you please tell how many files are using to make the VNF's onboarding? I need to just read that again because I'm not sure I understood it. Could you please tell which?
Okay. Yep. I see the question from Wadi there. So the files, I mean, essentially we work with what we're given, right? So we've done a lot of these plug tests, et cetera, right? And different vendor, as everyone understands, you almost have two aspects of this, right? There's the evolving standards. EnterpriseWeb has a harmonized model, so everybody understands. So this answers Chitra Basu's question as well. So, TMF has a harmonized model that includes TMF Open API concepts, 2GPP, 5G concepts, MEF concepts, MEF concepts, as well as TMF, MEF, 3GPP, and NFV concepts, SOL specifications. So there's actually many versions of SOL as well, right? So Enterprise Web has a model, a harmonized model that it's a graph that maps those all together logically, because they don't just naturally plug together. So Enterprise Web gives you an out-of-the-box, ready-to-use operational model that already has all of those standards. You can extend it with your own internal telecom operators standards, your own information models. So that's one aspect. The other aspect is that the vendors comply or conform to standards to varying degrees. Even the VNFD standard doesn't have 100% support, right? And we see everything from REST to Yang to everything, right? We still see some SOAP, and so Enterprise Web actually enables the vendors to onboard quickly. You can actually expose a self-service portal to vendors if you'd like, or have your own teams do it. But they could onboard quickly with whatever the resources they have, right? The files, the images, etc. And Enterprise Web will consume that, introspect it, and it will. Enterprise Web's essentially type system is looking to sort of automate the mapping to that higher level model, to that harmonized model. So the better starting point that we get from the vendor, the faster and more complete the object we create in Enterprise Web. And then, of course, and so there's no specific set number of files. It's really, we work with whatever, or the system works with whatever the vendor or the person onboarding has, but it can unpack a SASAR file. The system can do it, right? You upload a SASAR file, it unpacks it, it actually does automatic entity extraction, and then it does algorithmic mapping, all on the fly. I mean, at sub-second speed. So, Enterprise Web is set up to make it flexible, to work with the vendors and drive them towards conformance so that they can participate in your services. So I hope that answers Wadi's question and Chitrabasu's questions. They're actually perfect questions. But for today's call, I want to make sure we get through to the automation part. So you'll excuse if we keep on moving. But thank you for the questions.
Great. Thanks, Dave. Okay, Bill, back to you.
Awesome. All right, so just a reminder, I'm now playing the role of a service designer who's going to actually do that modeling of the enhanced 5G core service. So I'm going to go ahead and do that. And as I mentioned earlier, all of these modules are like similar. So onboarding would be a very similar process to this, just it's supplying different kinds of inputs really for the thing that I'm trying to add to the system. So I'm going to go ahead and model a network service template. I have a little cheat sheet here just to pop back and forth so you don't have to watch me type this stuff out. And that's about all I'm going to really do as far as speeding up. You can see, though, that we support things like actually uploading that network service descriptor if you have it, and that would populate these actual models for the network service that I'm creating itself. So, we'll basically start with any of the if you want any starting materials that you might have and use that to bootstrap any of the modeling or creation that you have. So we've created this network service, and you're going to see that there's going to be standard things like parameters and so on that will be collected. What we're going to do is we're going to jump right to the sort of important part here. And as I walk through this, though, you're going to see that things like these parameters will be auto-populated by the system. As I upload things, like I'll actually use a CloudFormation template later. When I upload that, it will introspect that and be able to, basically guide me through creating the business logic that's sort of appropriate for that artifact. So I'm just going to start, though, at the very core, which is sort of the most, it is really the most core operation that we're going to do here, which is I'm going to select the components that I want, and I'm going to create my service graph. Right? So I'm going to actually look through the packages that have already been onboarded. And again, a lookup of the kinds of components that are, available to me. I'm permissioned as a user to deploy. So I want to do that Fortinet firewall as my first component. So I'm going to add it to my catalog, and I can start to do things, add it to the roster of components I'm going to use. I can start modeling it down here. And as I add the new components, what you're going to find is that I can do this sort of, I can do it all at once. I can do it, piece by piece. What I want in this case is to actually add my user plane. And I'm just going to give them generic names here. And what I'm doing is I'm creating my graph, and I'm going to connect up the components as I do it. And as I do this, I can really start to, how would I say it? By default, a lot of this, and I would say almost all of it, the configuration is relying on that underlying model that we have. It knows how to connect these components. If I drill in on any one of them, though, if I expand something like the user plane, for instance, I'm going to see the options that I have to be able to configure here, things like my host name, etc., that'll be inherited. And this, you're going to see in a minute, this is all, it's already starting to do things like, the properties that are being collected. It's already calling for a host name to be a parameter. Those kinds of things are nice. But I can drill in at any time, and we talked about the service chain, and these are things that are normally pretty complex. Well, what we're doing is we're surfacing it here. I can drill in on the component that I care about modeling. I can get a lower level view, and I can see that a lot of this has already been defaulted for me. That things like the firewall will protect the traffic, a couple of the other protocols that are really interfaces that I might want to be exposing, and it's aware of them. And then I can go lower and I can start to look at the policies that might be connected, right? So not only turning on and off things that might be involved in the service chain, and of course it'll translate this to whatever lower level, network service descriptors and so on are going to actually be needed here. But I can also go in and I can look at policies that may have already been modeled in the system. So we have things like, models for, certain class users, right? I want my firewall to only be included when the user who orders this, is a gold class user, those kinds of things. You can do that very easily here just through the UI. So we've pushed really all those things, made it as easy as you can to start configuring this service. I'm just going to add my other kind of core component to this, which is my control plane for the moment. And then I'm going to have a look at a couple of things, right? So I add my control plane here. Whoops, I don't want the OpenDNS. Sorry, picked it a little too soon. But you can see all of it's nice and easy to round trip these things. So let's pick the right component here. So I want to have my control plane. And of course, these are modeled separately. You can mix and match, leveraging the standards that are underneath this, so that I could have somebody else's control plane over top of the user plane, whatever it is that I have available. So I made the basic connections here. But what I start to consider here is things like, where do I want this as far as a VNF? Is this going to be a per slice kind of thing? So I want my firewall to maybe be, again, sort of lower level configuration, but made very easy here. The thing I'm considering here, though, is where do I want to deploy this service to, right? So right now I have options for, basically, if you want to call it that, the sort of concrete services that have already been attached. Domain hosts that have already been attached. But what I would like to do at this point is I'd actually like to go in and I'd like to upload a YAML file for the cloud infrastructure, right? So this is going to be a cloud config file that I've got here. And so what I can do now is I can actually go in and say, well, this is a CloudFormation template. The system recognizes any sort of compatible format that this might be. So it allows me to start doing things that are a little bit more interesting here. I can attach my CloudFormation template. And then what I can do is for my actual firewall, I can say, well, I want this thing to be either deployed to something new that the system will completely create, or I can see any compatible kind of host. In this case, remember that the K8 network that I had sitting up already, I can say that, well, I want that, but I want it to be augmented by what's inside this YAML file. I don't need to sort through it, figure out what the details are. It knows there's a VPC and other things that are going to be needed. It'll stand them up around that host environment. So I'm going to make a couple of choices as far as what that target is. And what this is really doing is that's pretty much enough. The system will be able to take that and start to generate a deployment plan, et cetera, from this. But there's a couple more options that I want to include here. The main one is that for this, I can either go with the default database that's actually been, it ships with the Open5GS, Mongo, whatever it is, or I can go with this becomes the real value add. I want this to be on AWS. So I want this to be an integrated service. I want to build those couple of things in to make this enhanced more than just a firewall. I also want to use a better DB. I want better integration. I want automatic DNS mapping and stuff like that. So what I'm going to do is I'm going to update my service graph. Instead of deploying packages and so on, I'm actually going to look for things that are already onboarded, services that I want to use here. In fact, I want to use this document DB. So that's one of the pieces here. So this will be my DB. And then what I'm going to do is I'm going to say, oh, I'm going to connect that to my control plane, right? So my control plane can use that database. So now what I'm looking at here is when I when it comes to configuring, and this is, again, this is the kind of business logic, right? This is actually, this is the only detail that you really need to understand as a service manager is, these are the kinds of components I have. These are what's available. So it makes it easy for me, in this case, say, well, this is the database I want to point to. There's no, literally no integration that's going to be required there. It even generated the configuration files for me, the indexes and so on that would be actually deployed with this. So my options really become, pretty easy. I can download these at any time, update them, and this becomes, of course, really nice if you're a carrier and you're deploying something with hundreds of interfaces. You can download your config or use standard ones that you've created rather than using a UI to create them. But all those kinds of lower level details are already, if you want, baked into the tool. I'm going to add just one more thing here. I want to add that Route 53 service. So I'll get that in here. So I'm going to call that my DNS. And then what I'll do is I'll just connect that up to my firewall. So it'll automatically be sort of in sync with the service itself. So I've created a nice little service here. I could set additional parameters if I want, things like the host name, for instance, which is the only thing I'll really do here as far as parameters go. But you can parameterize this thing as low down as you need. And you can see if you do the modeling itself with things like a virtual service or a VNF, a CNF, etc. You're really talking about just gold configs, right? These are the kinds of things I want the service designer to work with, and I want all the lower level detail to be modeled for me. So this takes care of it. What's nice though is that I did this, and a lot of information you can see was already filled in for me. Things like what the components were that were going to be needed, and even attached things like a controller for Enterprise Web. But now what I'm looking at is the actual generated workflow that's going to be created for this thing, right? So we talked earlier that it was going to be a multi-stage process, and right now it's actually going out connecting with the things like determining, what CloudFormation templates, et cetera, will be actually used in this. And you can see that my process model now matches pretty much what you saw on the slide, right? And this was all generated based on the details that we had here. But so it's things like, do I bind to an existing stack or do I use a new one, right? All those choices are going to be made, I guess I sort of inferred what they were going to be as I added different artifacts, made different business choices, but this was all built for me, and it's something that can now be edited. There's even a check task, I can put into various stages here. I'm just going to get rid of that from my workflow.
Just to point out for people who might not be familiar, this is called a state chart, right? So just like that slide I had, so it's got several stages. Within each stage, there's several tasks, as opposed to a flow chart, which could fill up an entire wall of a large room. This is an event-driven process, right? So the system is going to just follow logical conditions, work through all the tasks that are applicable, and then move on as directed. As a state chart, and this is going to get executed as a data flow process, it will automatically make parallel all tasks that can be made parallel, and then the stages are sequential. So any tasks that can be run concurrently will all be run concurrently. Nobody has to worry about programming that, because that's actually very tricky. And then managing parallel processes is also very tricky to do. So Enterprise Web is actually generating this state chart for you of an event-driven process. You can drill into it, and you can manage any one of the discrete tasks with any details. But essentially, it works right out of the box. Most of the time, you won't have to touch it. And though we always give access and visibility so people can go down and then go. And then this becomes something the system, the runtime, will just execute. So it's generated its own connected workflow. You don't have to worry about where things are. You don't have to worry how things integrate. You don't have to worry about the order of work. You don't have to worry about protocols, right? You don't have to worry about any of that. It's a no-code environment. The runtime handles all implementation complexity. So Bill, with not a lot of time left, we should sort of pick up the pace. That was been really good so far, but let's pick up the pace.
Yep, and I think it'll go pretty quick from now. We've really done all the, if you want, work that's going to be required here. We're just going to add this thing to our catalog, and then really now what we're going to be doing is just using this and then observing it in the system. You can see that it's already been added to my catalog here. So it's something that, I could look at the inventory inside the system if I wanted here. You can see there's no instances of it yet, for instance, that kind of stuff. So what I'm going to do now is I'm going to switch gears, and I'm going to actually play the role of a business customer in this case who's going to order the service. So I'm going to go into just a simple, sort of sample portal that we put up, right? So what this is, it's tapping into one of our APIs or northbound APIs for the catalog that's exposed by the system. And of course, there's a number of things you can go into beyond this, but they're all standards-based APIs for ordering. What I'm doing is I'm able to have it examine what those products are that have actually been onboarded in the system and made available. You can see a few of them here. So what I want is that 5G core with a firewall, and just really it's already got things like the host name and so on. So it's revealing to me the instance name. So I'm just going to place that order. So pretty simple as far as the ordering goes, but all the APIs have now been run. Let's just log into this dashboard quickly here. We should see it start to stand up. So it's going to take a second here to actually get going. But yeah, you can see, just wait for it to load. But you can see the deployments are starting to stand up. Things like the pods, the replicas, etc. All the whatever lower level detail that's needed here is actually executing. Now I'm going to switch gears. I'm going to be that NetOps engineer, right? I'm going to play the role of somebody who wants to observe this service that's been ordered and what's being stood up. And of course, you can do all this through the APIs. But if I go back into the system, I'm going to just look at the system inventory. And I can do it from the different various modules. I can do it from that original catalog if we want to see everything. But what I'm doing now is I'm just refreshing the system here. And I can see my new instance is actually active already, right? It's been stood up. I can see what template version was used. And I get this sort of, it's kind of nice. I have an inventory of all the, in this case, VDUs that have been just deployed, what's shared across slices versus what's independent. I can see the various components from a firewall to an actual eWeb application controller that was stood up, a user plane, etc. components. I can click through any of them and see like sort of where they are, right? So I can pop open to the Kubernetes pod that it's attached to, a minute ago, what have you. So I can see things like the health, et cetera, that the system's monitoring for this service. I can look at the things like the trace or deployment trace. You can see that a few things like the configuration will be surfaced for me here. But when I'm looking at the lifecycle, if there are any additional events, scaling, et cetera, they'll all be listed here. I can go in and see exactly what the system's doing for each of these. And that trace gets pretty detailed. Everything from the order to creating the identity of the service to which components in the CloudNFV are actually being used. Our resource manager, for instance, for figuring out the dependency graph, it talks to CloudFormation at certain points.
And this is sort of the other side of the coin for being model driven, right? One part of it's been all this automation that we're benefiting from. The other is this global transparency, right? I've talked to so many telecoms that are struggling with cloud native tool chains. And when something breaks, trying to identify where it's broken because it's not transparent, it's not clear. Or if something gets, if you update one tool in your tool chain, what's the impact of that? Well, you don't necessarily know. So this global transparency, it makes it easy to test and debug, right? Everything's surfaced. Everything's been modeled through the system. The system understands everything that's being executed. It records every task, everything it's done. And if there's an error, it surfaces the error as well. So it executes as far as it can. If execution fails, it reports the execution failure at the point of failure. So the idea is to not only make it easier to automate and deploy, but also to manage, debug, right? Trace. Global transparency is critical in that regard.
Yep. So what I'm going to do now is we could spend a lot of time going into the detail there, but I'm going to switch gears now and I'm going to do almost the same process, but I'm going to do it with a customer app and show you that it's really just the same kind of thing. It's just going to be leveraging really existing assets, right? So I'm going to play the role of a business customer who wants to order an IoT app over this network that was deployed. The only real difference is here, slightly different portal, and all I'm doing is tapping into a different subset of the ordering API, different class of product, really. You can see a number of them that are in here, and these are our IoT customer apps. But what I'm looking at is if I pick something like Homebridge, for instance, which is the one that I want to deploy, what it's going to do is pull all those, that model of gold params that are needed here. But you can see also things like my actual target host, right? I can either have it deploy a new EKS stack to run with this, or in this case, it's the default that I just created. It's the one that's actually applicable or, basically that meets the demands or dependencies of this particular app. I'm just going to go and let's see, do I want any other detail? I think I already have, yeah, I already have the host name I want. I'm just going to change the instance name, and I'm going to go ahead and place this order, right? So this is going to go and actually, deploy again, orders placed. So I could look at it through the APIs, and of course that would all be set up in your ordering portal. You can query, the statuses of these things, but they're already pretty much, it's already pretty much done. So what I'm going to do is log in as a NetOps engineer, like I did before. Just look at my inventory here of the particular component that we actually just deployed. So I'm going to go ahead and I can see my inventory here slightly different module, different components that I'm actually looking at. I want to see that home bridge. So I can look it up really quickly, very easy. It's a customer app that we've onboarded. I can look at things like the instances here, and I can see that in this case, I have my one instance that's been created. I can go in and actually look at the deployment details. I can see it's healthy and active. I can go in and look at the pods that were deployed, same kind of thing, right? It's going to connect me through to whatever the underlying component is, 48 seconds ago. It's going to allow me to actually log into the app itself, and I can see things like the deployment itself. So I'm going to play the role of the customer here. They'd, of course, have the UI, what have you, over top. But here I am in the Homebridge app itself. Things like the logs, what have you, plugins, configs, what have you. But this is the actual customer app that's now been deployed, standing up over top of that network, connected again right through what would be that sort of enhanced service offering. So things like the firewall are in place automatically for me. I don't have to do any of that manually. So that's, I went through relatively quickly here, but I covered the scope of the demo here. So I'll pass it back to Dave, and thank you very much, and look forward to the questions.
Thanks, Bill. Hey, Dave, you got about 10 minutes.
Okay, great, Bill.
Yep, I stopped.
See my screen. Well, I hope that was clear. Obviously, again, we're covering a lot of ground. Hopefully, if you want to watch the replay at another time, you can watch it at your own leisure, at your own pace, and move through it. We just want to make sure we got through the scope.
Just could you just go on to full screen there on the?
Oh, yep.
Yeah, yeah, great. And Dave, just before you kick off, can I just read out a question from Takato Ando from SoftBank? It's amazing to have a packaged software of network functions like MME, HSS, SGWX. Do those software work on AWS, right? I think you said it did. How software package can perform and control each other. Is there any real customer operator network trial or test you can relate to? And he'd like to know your kind of architecture performance compared with legacy big vendor ways. So that's Takato Ando-san from SoftBank.
Well, that's a great question. Bill, I don't know if you want to tackle maybe the first part of that question about the MME and things like that as far as deployment. Where it is being deployed on AWS in this demo, but if you want to fill in any color there.
Well, I mean, the truth is that these the services themselves are kind of how I say it, there's what people talk about with being able to just deploy them into they say there's Kubernetes underneath, you can deploy it anywhere, but the truth really becomes that you really need a model of the deployment target that you're looking at. So in the case of AWS, you need to know about those services that are there that add value. And you need to be able to really tailor it to the infrastructure that comes up. So you need a model of things like CloudFormation that will be below it, the available services like you saw DocumentDB, Route 53, etc. So what we have is something that, yes, it's the Open 5GS, or I guess you could say any vendor's kind of VNF, but what we have is something that is really optimized or well fit for the actual infrastructure that's deployed on. So here with AWS, you have something that's optimized for basically their deployment infrastructure. And I'm not going to speak to specific, other, targets that have been deployed, but you can imagine that another cloud carrier.
So we're an Amazon partner, and clearly we have, which we're very excited about, and Amazon has tested and validated this use case. And we're hybrid multi-cloud, and we're deployed in tier 1. EnterpriseWeb is our CloudNFV solution is deployed in tier 1 environments. And our internal benchmarks have shown us orders of magnitude more performant than any other solution that we've been compared to. So comparing us to like any other kind of middleware stack technologies, enterprise service buses and sort of older middleware generation technology, 1 to 2 orders of magnitude better performance from Enterprise Web, because we are completely cloud native and completely optimized for that. Even comparing against cloud native tool chains, like Kafka is great if you want to just do something that's broadcasting lots of events, but Kafka by itself is not a complex event management system. That's exactly what Enterprise Web is giving you, a cloud native complex event management system. If you compare it head-to-head in objective benchmarks that we've run internally, we're happy to review you, Tanaka-san, offline or anyone else on the call. In our documentation, 100 times more performance or more than a Kafka-based solution trying to do the same use case. And we actually went out of our way to make that objectively fair. We didn't rig those tests to our benefit. These use cases, these telecom use cases, are complex on their face. Addressing them in any other third-party tool chains is just hard. And Enterprise Web, by bringing everything under a common abstraction, under common cloud-native tooling, by rationalizing tool set, we're gaining tremendous benefits. Actually, that's where I'm headed. So I hope I addressed that in short, and then I'm happy to address offline. Again, I appreciate all these questions. So going just through some benefits of this demo. Rationalized tooling and unified management is the first benefit we want to showcase. So right off the bat, if you go to the Amazon blog, you'd be looking at an extended tool chain, and that's sort of standard in telecom solutions. We're seeing some pretty crazy tool chains of incumbent vendors and mixed with cloud native stuff, and they're not even telling you how that stack got integrated or how that stack will be managed. That's problematic. Enterprise Web is rationalizing the tool chain. We're saying, well, you don't need non-differentiated middleware or non-differentiated tools. You want to focus. You want to get really want as few tools between you and your use cases. The more tools you have in your chain, the actual less flexibility you have, right? It's an inverse relationship. The more simpler and more unified your chain, more comprehensive and holistic it is, the more performant it's going to be, the more control you're going to have. So we're able to eliminate a lot of components across the board to make things more streamlined. In addition, because we're end-to-end connected by one harmonized model, we're able to do things we're able to extend things flexibly, flexibly and adaptively to customer interests, to any specific telecom's desire for their implementation, to extend it with their own information model concepts as well, so that their compositions are their compositions. And so in this case, generally if you were to manually integrate this service could get done obviously otherwise, but it'd be pretty siloed, probably pretty vendor-centric, and pretty tough to extend or modify. In Enterprise Web, you saw Bill throw in the document DB with Amazon. You saw him put the Fortinet firewall, point and click, right? No manual integration, no worrying about the messaging, no worrying about how transactions are handled. We're also at a lower level getting an improved implementation, right? So in addition to the EKS control plane, we're adding an Enterprise Web CloudNFV application control plane, right? So we're now giving you a higher level application control plane for the end-to-end management. And with the presence of our control plane, we're able to eliminate other lower level components. And we're providing a level of abstraction that's going to enhance security. There'll be now no direct application access, so that this is a better architecture and a more secure architecture for your 5G core. So this almost adds on to Tanaka-san's question. So if that's really it for our presentation. There's my email at the bottom, david@enterpriseweb.com. We really appreciate everybody's time. Well, actually, we have several minutes left, and like I said, Bill and I are happy to stay on the line. I'm going to look at see if I can see the chat box here.
Yeah, I got it, Dave. Anyway, don't worry.
Okay,
Don't
great.
worry, I've got it. Listen, I've got one question for you in the chat box. Questions from Joe at US Cellular. Here you go. Impressive demo. So congratulations, guys. How does this scale when an operator has to manage thousands of instances, such as what Bill has shown?
So Enterprise Web is truly, as everyone on this call knows, there are a lot of buzzwords in the cloud, and there's a lot of buzzwords in telecom. So a lot of people say the same things, but don't give the same results. Enterprise Web is truly model driven. It is connected end to end by a singular model, and it is truly cloud native. So that model is based on cloud native persistence. Our databases are distributable. Our indexes are distributable. All the Enterprise Web functionality, and this would take a longer conversation, is actually delivered as event-driven serverless functions. Enterprise Web literally is 100% dynamic. So the cloud-native model, the model is actually kept in memory. The persistence is done in cloud-native storage. We generally run over Cassandra. Our indexes are distributable. Our databases are distributable. Our nodes, our modules are distributable. And our runtime is 100% dynamic. Everything is a real-time interaction. Every event, every client request is processed for its real-time context, which means that we actually have a very small attack surface as well, because literally everything's evaluated in that moment, and it's an ephemeral moment. If security policies change somewhere else, we're literally locking people out or changing things. We can control the system very tightly. So Enterprise Web is truly cloud native. The question and all these questions warrant deeper exploration, and I'm happy to do that offline. But hopefully that answers it in part. A cloud native runtime, cloud native persistence, in memory model. We're doing a command query separation for those people who understand those, reliable messaging. So this is all very scalable, reliable messaging. Enterprise Web is item potent. It's immutable. All our objects are immutable. So, but we're hiding all that because honestly, being cloud native is an engineering challenge, even for PhDs. Enterprise Web is abstracting the PhD. Right? It's all transparent. You can if you want to drill into those details, we can show how everything's connected by our graphs, by our type system. But the whole point of being a programmable telecom is to not worry about the how, just to focus on the what. To focus on your business needs, your business requirements, your services, your service logic, your applications, and your customers, and not while making the implementation transparent and controlled, but by hiding the implementation detail so that you don't have to worry about it on a day-to-day basis or moment-by-moment basis. Because it's just your environments are just too darn complex, and they scale. The size of the scale and complexity of them is actually really beyond immediate human intervention. So you need systems that can do that. Also, our northbound API, you saw it being used for ordering. It's also, of course, completely available for AI, ML, and analytics, higher level course customer portals. We've worked with Amdocs before on customer management. We can work with any third party, and we can work in a very federated way. So, but AI, ML creates a way that you can then bring higher level analytics and both monitor Enterprise Web and also drive, Enterprise Web can invoke algorithms to get higher level analysis that could then further optimize its runtime performances.
Okay, hey Dave, we're just about out of time, but I got a couple more questions if you don't mind just hanging on. So first question actually came in on the registration regarding security. You mentioned security earlier, and the question is regarding security for automating of deployment of 5G core and orchestrating programmable infrastructures. How would you determine the proper security and educate customers for that?
So there's security happens, at many levels, right? So obviously security, thinking about security and SASE and things like that is evolving in the industry. And we work with industry standards and industry thinking, as well as then there's EnterpriseWeb's approach, right? How do we implement security, system security, data security, right? How do we secure our UIs, our APIs? How do we secure data at rest, data in motion? And then there's actually the design of Enterprise Web and making sure that our footprint is our attack surface is as small as possible. And then there's RBAC and ABAC. So security, it's a fair question. I think we contribute to it, but we don't give you the full answer because part of that is, well, we don't control every endpoint. Even Amazon and all the other cloud providers have sort of worked towards this collaborative security model, right? They're providing security for their aspects and working with you on securing the whole end-to-end. And Enterprise Web would be part of that end-to-end model as well. There's a term for that. I forgot what it is. It's not collaborative security.
Okay, Dave, and just one last question. Again, thanks for an interesting demo. Can you comment on Service Assurance Framework and it's possible to integrate probes? And is it possible to integrate probes?
Absolutely. So we've collaborated with many people. So Enterprise Web, on its own, as you saw it with this demo, Enterprise Web can do monitoring through the connected interfaces, through the protocols that are established with each connected solution element. And we could do that in an event-driven basis. We can do that through SNMP. We can do that through polling. We can do that through REST queries. We can do it whatever each element allows us to do. So that's the basic bare minimum there. However, we've worked with Expo, we've worked with Spirent, we've worked with many other partners, Cosmos DPI. We've worked with many others in these chains that are putting probes into the network, that are doing resource monitoring and service monitoring for a more comprehensive approach, where they have optimized tooling for those purposes, whereas Enterprise Web is providing a general platform for it and can do it end-to-end, but we would absolutely work with third parties. We not only would, we have, and we do. We have many friends at Spirent, we have many friends at Expo, Cosmos, and elsewhere, Fortinet and elsewhere in the network. So we can absolutely support every customer's own preferences for vendors, and we're happy to collaborate with, obviously, with vendors directly as well for their service assurance needs.
Okay. Hey, great, Dave. Thank you very much. Bill, thank you very much for the demo. We've had a few people obviously commenting in terms of thanks very much, very useful. So really appreciate it. Really looking forward to the next time. I think you're also presenting in one of the virtual workshops that's coming up. So again, thanks guys, really appreciate it. Unfortunately, we've run out of time. So thanks everybody for coming on the call today. And we look forward to speaking with you, hearing you, engaging with you in the coming weeks and months. And at some point, of course, I'm sure we'll get back to a face-to-face workshop. So thanks, everybody. Thanks, David.
Graham.
Thanks, Bill.
Thank you so much, Graham. Thank you, everybody. Bye-bye now.
Bye for now, everybody.